Indefinite integration, problem 17. The gradient function curve C is given by dy dx equals x plus 2 times x minus 2 over root x, where x is greater than 0. A. Show that dy dx in the form of ax to the power 3 over 2 minus bx to the power minus a half, where a and b are integers. B. The point 175, that's x and y, lies on C. Find the equation of C. Well, dy dx is x plus 2, x minus 2 over root x. The numerator reminds me of difference of two squares. In difference of two squares, a squared minus b squared equals a plus b times a minus b, where a is x and b is 2. Dy dx can be written as x squared minus 2 squared over root x. So dy dx equals x squared minus 4 over root of x. Also, with indices, if we have root a, and that can be written as a to power a half, and 1 over root a can be written as a to power minus a half. So we're going to apply that here. Dy dx equals x squared over root x minus 4 over root x, because they have this common denominator, and that can be written as x squared times x to the power minus a half minus 4 times x to the power minus a half, because that's 1 over root x and that's 1 over root x, and 1 over root x is x to the power minus a half. Therefore, dy dx equals, you're multiplying the same base, you add the power. Therefore, x to the power 2 minus a half is 3 over 2 minus 4 x to the power minus a half. And that's the first part of question A. In question B, we are to show that the point 1/7/5 lies on C. We need to find the equation of C. That means we need to find y, and y is always the integral of the gradient, which is dy dx. If you're not sure how we got that, the gradient dy over dx equals x to the power 3 over 2 minus 4 x to the power minus a half. Multiply both sides by the x, so you get dy equals x to the power 3 over 2 minus 4 x to the power minus a half dx. Now that's dy dx, right? So dy dx times dx. So if we integrate both sides of this function, we get integral dy equals integral x to the power 3 over 2 dx minus integral 4 x to the power minus a half dx. And if you integrate dy, you get y. And if you're integrating x to the power 3 over 2, you get x to the power 5 over 2, because you add 1 and you divide it by 5 over 2 minus 4 x to the power a half, because you add 1 divided by a half plus c. Therefore, this is 1 over 2, and that's 2. So y will be equal to 2 over 5 x to the power 5 over 2 minus, that's 1 over 2, which is 2. 2 times 4, 8. So that's 8 x to the power a half plus c. Just remember, when you're integrating y equals x to the power of n, integral of y dx will be equal to x to the power of n plus 1 over n plus 1 plus c. And that's what we've done here. Just to remind you, if you're integrating integral of y to the power 0 dy, because y to the power 0 equals 1. So that's why we put y to the power 0 for a constant. If there is a constant, it's multiplied by y to the power 0 in this case. And that would be which equals y. So that's how we got y. If you integrate into y, you get y using that method. And that's how we got that one. And this one is this one here, which is that. We need to find c because we know the value of y and x. So y equals 2 over 5 root x to the power 5. That's what that is. That's a half. A half means root and x to the power 5. So remember, root of a is a to the power half. So that would be minus 8 root x plus c. Now we need to find the value of c when x is 1 and y is 7 over 5. So that would be 7 over 5 equals 2 over 5 times 1. 1 to the power of 5 is 1. Root of 1 is 1 minus 8. Root of 1 is 1. So that's 8 plus c. Let's make all of them common denominator. Over 1 over 1. So that's 7 over 5 equals 2 over 5 minus 40 over 5 times 5 times 5 plus 5c over 5. Because they have common denominators, only the top counts. So you just ignore the denominator. So that would be 7 equals 2 minus 40 plus 5c. And that would be, well, 40 minus 2 is 38. 38 plus 7 is 45 equals 5c. Therefore, c equals 45 over 5, which equals 9. So the equation, we replace c with 9 here. So therefore, y equals 2 over 5 root x to the power of 5 minus 8 root x plus 9. So that's the solution that we're looking for.